Okay. Well, everyone, welcome to Miami. Welcome to NANOG 24 and the routing policy tutorial. My name is Dan Golden. I work for Sockeye Networks. We're a routing optimization company up in the Boston area. Basically, what we're going to be talking about today is routing policy. Now, the question is, who's the audience for this sort of presentation? The audience is network engineers with a basic knowledge of BGP and internetwork routing. If you're some kind of incredibly knowledgeable BGP guru, this presentation may be of limited use to you. Luckily, there's few of those people. If you don't know anything about networking and you're like OSPF who, then this presentation may also be of somewhat limited utility to you. This presentation is really for people who have a good basic knowledge of IP routing, a good basic knowledge of inter-domain routing, and want to be able to take that and write policy from it. Take that and write documents and write policies for their networks or for the networks they serve. So the question is, why are you here? To learn and discuss network and routing policy and to help your networks expand into new horizons. And by expanding into new horizons, I mean, let's say you have a network, and it could be a service provider network, it could be an enterprise network, it could be an enterprise network becoming a service provider network. It could be any of these things, and you want to do stuff like offer transit to your customers. You want to do stuff like start peering, which is these days becoming more and more common, even among large enterprise networks. In order to do these things, you really need a decent routing policy, a well-documented routing policy. Now the questions are, why aren't you here? The reasons why you're not here to learn what a route map is, because route maps aren't really routing policy. Things like route maps and policy statements aren't routing policy. They're how you do routing policy. So we're not really going to do any like Cisco or Juniper syntax, although you may see a little bit kind of floating throughout the PowerPoint here. And you're not here necessarily to learn BGP or the routing protocols. A lot of what we're doing, if there were multiple exterior gateway protocols, would probably be protocol independent. But since we only have one, since we only have BGP, it is very BGP dependent, but this isn't a session to really help you learn BGP. There's some really excellent presentations in the NANOG archive for learning BGP. As far as questions and comments, please be interactive. If you have a question or a comment, please shout it out, please say something, please stand up. If you want to, you can come up to the mic and talk. If you don't want to come up to the mic, you can just shout it out. It's not a big room. I'll repeat the question back to you and then either answer it or solicit someone in the crowd for an answer. Let's just start out. The question is, what is routing policy? As we said before, it isn't route maps. It isn't a peering policy. It isn't a filter policy like a prefix filtering policy. And it isn't a set of standard router configurations. But these can all be aspects of a good routing policy. These are some of the things that you want to put together and collect, and once you have them all together, they're aspects of a routing policy. But what a routing policy really is a single overarching document that encompasses all of these things or that has pointers to all of these things. So let's start out with a definition of what is a routing policy. Now, I don't expect this to be sort of a canonical definition of a routing policy, because if you ask 10 different network engineers, hey, what's a routing policy? You're probably going to get 10 different answers. So this is kind of a good approximation of it from looking at a lot of other people's routing policies and saying, okay, if I take sort of the union of this big set of routing policies, what do I get out of it? And what basically I saw through all these different routing policies, both at companies I've worked at and at probably most of the major providers, is it's an expression of a network's goals. So in other words, it's not necessarily what you're doing today, and it's not necessarily maybe what you're even going to be doing tomorrow, but it's usually what you hope to be doing eventually when you get all your stuff together and you manage to get caught up on your maintenance and you manage to get all this stuff deployed that you really want to get deployed. So it's the expression of a network's goals for a selection of routes that you accept from your peers, your customers, and if you have them, your upstream providers. It's an expression of goals for selection and modification of the routes you're sending to your peers, customers, and upstream providers, and it's a methodology of identifying routes within your own autonomous system. So basically, it's a routing policy. It's all about routes. And when it comes down to it, the routes you send, the routes you receive, and the routes within your autonomous system. And it's about classifying them, about measuring them, about identifying them. Now, why is a strong routing policy necessary? And again, by strong routing policy, we mean some sort of written document specifying what your network's routing policy is. And there have been, and I'm sure there still are, many large networks out there with absolutely no routing policy in writing at all. They have some disjointed collection of documents. They have a peering policy over here in this department, and over in that department they have a filter policy, and they have a set of standard router configs, and well, maybe they don't, but maybe Rancid gets all their configs every night. You know, there are plenty of networks like that out there. But there are good reasons, especially if you're starting kind of fresh, to have a strong routing policy. The first reason is scalability. It's very easy to have one peer, and it's very easy to have 10 customers. When you have 50 peers, or when you have 200 transit customers, doing things without a strong routing policy gets you into trouble because everything becomes a custom operation. So scalability, being able to scale to large numbers of peers and transit customers. Troubleshooting, enabling identification of where routes are entering your network. Usually important, especially, not if you have, one data center somewhere with, one edge router with 2 transit connections. Well, then you kind of know where the routes are entering your network, and you know where all the traffic's entering, and you know where all the traffic's leaving. But if you are getting into a network that's expanding to multiple data centers, if you're getting to a network that's expanding to have multiple peering points around the country, or multiple points around the country where you have transit, then it becomes very important for troubleshooting reasons to know where you're getting routes from at any point in your network. And a strong routing policy and a strong community implementation can help you do that. Also, customer features. A big part of routing policy, especially as it applies to BGP, is the use of BGP communities. Now, a lot of providers now are implementing strong community standards with strong community strings, and these are a huge plus for Klufel customers because they enable you a Klufel customer to do things like only take certain routes, to know what routes you're getting, to influence the behavior of your traffic on a provider's network without calling the provider and finding your way through 20 levels of support. So a number of large providers have done this. It's really a great thing. Cable and Wireless recently did this, kind of made the news, so to say, which was a very good thing. And there's a number of other providers out there who do it. Maybe, other major providers, at least half of them do it, and some of them actually claim to support it. So, what are the elements of a routing policy? Basically, written documentation, a policy document. And it's not ridiculous for this policy document to be 20 pages long. If you start counting in things like your peering policy, standard configs, bilateral peering agreement, your filtering policy, your customer-facing BGP documentation, there you could easily be talking about 50 pages with it all put together. Of course, this doesn't live in a binder, right? This lives on a web page somewhere. And you want to be able to handle different types of routes differently. The 4 kind of primary classifications, and these can be split into many, many other kinds of classifications, are customer inbound and customer outbound. Of course, customers in theory pay us money, so customers are good. We want to treat customer routes special. We want to treat customer routes different from any other kinds of routes. And the other 2 kinds of routes are, of course, transit and peering routes inbound and transit and peering routes outbound. Sir?
Do you see this as part of a service level agreement in terms of implementation?
I don't think it's necessarily unreasonable to expect an upstream to have some kind of a strong routing policy. And if you're going to select transit, if you talk to a company and they don't really have a strong routing policy, and if they don't have customer-facing routing policy documents, I take a strong look at them. Now, most companies aren't willing to say, okay, here's a binder with our routing policy in it, but they will have pretty large elements of the routing policy, like the customer-facing BGP policy, peering policy, bilateral peering agreements, and these things should all be customer-facing. Filter policies, these should all be customer-facing. Yes, sir?
I suggest that if your global infrastructure is managed by your service provider, that's when you want to have, make sure that they have a strong routing policy.
Yeah, I completely agree with that. Definitely, if your global infrastructure is managed by someone else, you definitely want to see the routing policy. And of course, all this stuff can be under NDA. But a lot of people are very concerned about how much of this they make public. I can only urge service providers to make more of this public rather than less. I think a great example of this, just to pick a network out of the air, is the old Digex network, which was IBI, which is now owned by Allegiance Telecom. If you go to their website, you can see, great customer-facing BGP document that has all kinds of details that are missing in a lot of kind of marketing-driven documents. But they're a great example of having, good customer-facing documentation without necessarily opening the kimono the whole way and saying, here are network diagrams, check this out. Other good examples of people who've done this in the past are folks like AboveNet, who had public and may still have publicly available MRTG graphs for everyone to see. Cable and Wireless has done a nice job with this. They have all their communities out on display, and as part of having all their communities out on display, you can see who all their peers are. So, very good kind of public disclosure. And there's no point in keeping this stuff secret. Everybody knows this stuff. No one is, anyone who could really replicate this stuff already knows this stuff. So by keeping this stuff secret, you're not really doing anything but sort of being clannish. So to start going into some of the elements of a routing policy, customer routes inbound. Okay, this is an example, and this won't apply to everyone, but if you're going to start providing transit to people, and if you're going to start providing transit to people, and this isn't necessarily, I'm selling a DS3 today. This could be, we purchased a company and we have to provide transit to them, or internet access, or whatever they call it. They may not call it transit. This is a situation where you may have some kind of a partnership. But in any case, you want to take people and give them all the routes you've got, and you want to take certain routes from them. And you want to be kind of careful about doing it, but you want to treat these people well because they're either part of your company or there's someone who's paying you money for transit. There's some kind of relationship there you want to preserve. So there's a couple important points here when you're accepting routes from a customer or pseudo customer. Now, the first question is, what routes do you accept? Do you filter by prefix? Do you say, okay, customer, is there a list of prefixes that you have to send me, and I'm only going to accept those? Or do you just filter by autonomous system? Do you say, okay, anything with autonomous system X and the AS path I'm going to accept? AS path lists are definitely easier, but they're certainly not recommended. It's somewhat of a dangerous situation. Prefix filtering is highly recommended. There's a little more administrative overhead. It's a little more cumbersome, but the end result is a downstream customer of yours is not going to easily be able to send you a full internet routing table and turn themselves into a transit AS. Downstream customers of transit AS is bad. Whew, bad stuff. We don't want to go there. And there's a couple other ways as we'll go on to keep that from happening. Don't only rely on prefix lists because, how many people touch a customer's prefix list a day? How easy is it to leave a statement off at the end of that prefix list? And this happens every couple months to one provider or another, and they turn a customer into a transit AS. Bad mojo. Maximum prefix size. What's the maximum prefix size you're going to accept from a customer? Now, this is a very politically charged issue, so I'm not going to offer any specific opinion on this. /24 is generally accepted. Most people accept /24s from their customers. Most people will send, at their peering points, will send /24s on to other providers. Now, there's folks who won't, and I'm not saying there's anything wrong with that. This is just what most people do. There are reasons sometimes to accept smaller announcements. Sometimes if you have a customer who only has a fairly small amount of address space, let's say they're home to, they're talking BGP, but they're home to you and they're home to another provider and say 5 locations, and they want to be able essentially to route without having static routes in to all their other locations. Accepting /27s or /28s and then having an aggregate facing your peers is another way to do this. With the recent Aaron decisions, essentially saying anyone who's multi-home gets a /24, there's far fewer reasons to do this. In the old days, when people could be multi-homed but not have a /24 because they didn't have sufficient justification, this would come up from time to time. Just remember also, just because someone will accept, just because you can accept /24s doesn't mean anyone will listen to them. So when you're writing your customer-facing BGP policies, it's very important to have disclaimers in there and say, we will accept X, we will accept a /24, we will accept a /20, we will accept a /28. Whatever you decide to accept, but make sure the customer knows that other people aren't obliged to listen to those announcements. That just because you're accepting them, just because I changed my filter list to listen to someone's announcements, doesn't oblige my peers, doesn't oblige my upstreams to listen to them, particularly depending on where that IP space comes from. If it's coming from, say, legacy Class B space, things get very hairy very quickly in accepting smaller announcements. Another great thing to do for your customer routes inbound is to have trip points for large numbers of prefixes. In other words, say, okay, for a typical standard customer who's coming in, I'll accept 200 prefixes, and at that point, an SNMP alert will get set and go into my NetSync, my NetCool, whatever my monitoring system is, maybe at 400 prefixes, the BGP session gets shut down. Now, of course, you have to have some sense there, and you have to have some rules, and you have to say, okay, I might have customers who have more prefixes than that, but you're never going to have a customer who has more than 40,000 prefixes, let's say. So this is a very good way of alerting the NOC in case someone has made a mistake and screwed up a prefix list, and you're accepting too many prefixes from a customer, and it's a good way of protecting yourself. A lot of people say, well, that's not necessary. We have these safeguards. The customer would have to screw up. We'd have to screw up. Well, they will eventually. And the way you have a big internet outage is enough people screw up at the same time. Multiple outages, multiple mistakes will cause an outage. This is simply another thing you can do to make sure that won't happen. And it takes a little more intelligence. It takes a little better training of your engineers, because if you have a customer who has lots and lots of prefixes, that means you have to have someone who's smart enough to go in there and say, okay, they're legitimately sending me 500 prefixes. I have to kick up my trip points. But that's the price of having a safer network. Another thing people are doing, and this is happening more and more now, is auto-generation of route filters from IRR registration. In other words, stuff like RADB or RIPE or some of the internet routing registries. People are using tools like RTconfig to make different kinds of prefix lists, different kinds of access filters from registered route objects. Of course, keep in mind, those route filters are only as good as the information in the IRR. And for some folks, the information in the IRR, not so good. The other thing there is it's generally pretty easy to get a customer to tell you, okay, these are our prefixes. We've got these prefixes from our upstreams. We got these prefixes from Aaron. A lot of times, a certain degree of education is required on how to use REDB or different kinds of IRRs. That's not a bad thing, but expect a lot of either blank looks or silence on the other end of the NOC phone line when you tell them that they don't have a route registered. You have to have some tools ready. You have to have some kind of either Java tools or other things to help them register their routes, or you have to be willing to register customers' routes for them. So there's just a different administrative burden. Getting back to customer routes should have your highest local preference. Customer routes should always be preferred. The key reason for this is you don't want to be sending your outbound traffic to peers if it should be going to your customers. If your customers prepend a bunch to you, you could be in a situation where you have traffic actually on your network that's destined for a customer that's going to go out a peer or it's going to go out one of your transit providers. And you really never want that to happen. This may be a little controversial. People may say, well, it should be up to my customer if they prepend to me, but it's not unreasonable. Yes, sir? Yes. Yes. Can you stand up and say that a little louder?
Our customers are not necessarily there participating in our field, and they have their routes registered. And our upstreams are requesting that register those. And we are acting as a front end. Because we want to take the split responsibility and how solve it.
This is a difficult issue. Basically, what this gentleman is saying is that customers are unwilling or unable to register their routes in an IRR, yet upstreams are requiring that the routes be registered in IRR. So sometimes some of the transit providers in the middle, or the hosting providers, can be put in a bit of a tight spot. And what's required there is there's a couple of things that are required. And I'll just shoot these out there. One thing is you have to make it easy. So you have to have tools written, tools ready, tools on the web page. You can't necessarily expect a customer to have an email template and send an email template in to register their routes. Customers do not know how to register their routes. That's key. Hopefully, one thing we'll move to, a little closer to in the future is having a situation like RIPE has, where in Europe, if you get routes from RIPE, it's in RIPE's routing registry, which of course is not the case here with Aaron. Hopefully, we can move towards that, but there's still other problems. With smaller blocks of address space. And I think the only way to solve that is going to be more tools and easier tools for customers. You have to have some integrated way, possibly through a web tool, of saying, give me all the routes you want to advertise, and maybe at the same time you generate your filters, you can register the routes for them in IRR. That's not a perfect solution, but unfortunately, there aren't too many perfect solutions with customers who may not have the world's most knowledgeable network engineers. Does anyone here have any suggestions along those lines? IRR problems?
Well, no suggestions, but a point to consider is when you are selling transit, there is a question how much service to add to that network transit.
Mm-hmm.
If you are telling people, well, okay, we are only taking knowledgeable customers, you might just say in the contract, we are not providing the service to register your rules. If you sell a service that wants to make your customer all over happy, regardless of how good this are, well, okay, you get an obligation.
Yeah, and that's where we're at today. I mean, economically, you know, we have to face it. Anyone here who's a transit provider is in a position where they have to make their customers happy no matter what. Now, some people have tried to kind of recoup their expenses from doing all this stuff, from IRR registration, from turning up BGP, and they'll try to tack on a BGP turn-up charge. Unfortunately, salespeople almost always negotiate that away. It's like an install fee, and no one's ever willing to pay those. So that's sort of a common enough strategy, is some kind of fee to sort of recoup your labor in doing things like IRR registrations. My only advice is automate it as much as you can. Okay, so going on to customer routes. Basically, customer routes should have your highest local preference. Again, you don't want to be in a situation where someone is sending you a bunch of prepends, so you're sending routes for a customer who's paying you towards a peer who's not paying you. And there's a couple reasons for that. For one thing, you've got to assume that you're the highest quality transit and that the customer for anything on your network should be getting the traffic directly from you since they're paying you, since that's sort of a contractual arrangement. The other thing that's important there is that, you know, 95th percentile billing, you want to get paid, you know, you need to send the customer any traffic you can. And finally, you know, the other issue there is, we'll move on. Anyways, MIDs are also usually listened to for customers. The application, there's customers who have either multiple transits with you on one site or multiple sites where they have transits with you. So MEDs are almost always listened to for customer traffic inbound. MEDs are very infrequently used, but they're almost always listened to. With customer routes and with all the other kinds of routes we're going to talk about, it's important to set unique communities. And we'll get into this a little bit later in our discussion of communities. But it's important to use a route map or a policy statement to set the appropriate and unique communities for each type of routes on route ingress. Once routes get into your network, it's essentially impossible to set any kind of policy on them. So if you want to be able to control them when they leave your network, or control them at peers, control them at customers, control them at any point inside your network, make sure you mark them with a community as they enter your network. Now let's briefly talk about customer routes outbound. And by customer routes outbound, I mean the routes we're sending to customers, the routes we're sending to transit customers, rather than the routes from customers that we're sending out to peers. Now, you know, there's sort of a traditional choice here, which sort of be the full routes, partial routes, or default route only. You know, back in the old days when people had 2501s with 16 megs of memory and did this huge routing cable that at the time was maybe 40,000 routes, and I'm sure there's people here who remember when there were far fewer routes than 40,000, they had routers that just could not accept the number of routes they're being sent. So then it was very typical to just send a default route or to send partial routes. Now, partial routes are essentially, if I'm the transit provider and you're the customer, if I'm sending you partial routes, I'm sending you all the routes for my internal network, I'm sending you all the routes for any statically routed customers I have, and I'm sending you all the routes for any BGP customers I have. But I'm not sending you any of my peers' routes, and I'm not sending you any of my transit providers' routes. And when you ask for partial routes, the number of routes you get is very much dependent on who the provider is. You could be talking as little as 500. You could be talking about 20 or 30,000, or whatever WorldCom is up to these days. So it greatly depends on who you're talking to. And these days, it's kind of happening again. There's a lot of routers out there that now have 64 megs of memory. You know, the prodigal 3640 with 64 megs of memory with Ceph on that can no longer take 104,000 routes. So we're starting to hit this again in a few places. But of course, always the best thing to take are full routes. Now the choice, of course, as a transit provider is yours as to what are you going to offer to the customer. Are you going to offer these three choices? Some transit providers actually offer more choices. They offer whether to aggregate towards you or not. But these are three good choices to start with. And as I just said, full routes can be sent with or without summary aggregates. Many possibly most providers don't actually aggregate towards their customers for obvious reasons. Some providers, again, do allow you to choose a certain amount of aggregation. Remember that by providing customers with rich communities, they can do their own filtering. Leave it to them. A good example of this is, and you should probably always say this, so when someone says, I want partial routes, you should say, okay, I can give you partial routes, or I can give you full routes, and I can tell you what my community strings are. And by doing that, you can do the filtering yourself. You can decide what routes you want, and that does two good things. If you ever want full routes, you can just take your filters out. That's an advantage. That's an advantage to you, because then you can do it on the fly. You don't have to call me. You don't have to wait in a phone queue for a long time. And it's an advantage to me because I don't have to waste, my BGP knowledgeable engineer's time or my NOC engineer's time necessarily dealing with a customer. So it's a win-win for people just to take full routes and to do filtering using communities on their own side. The problems there are that you're kind of locked into what communities you use. You can't go change your communities right on your customers then, or you're going to crash their routers, which is not cool at all. And in addition, you have to have customers with a certain degree of engineering clue. They have to know how to set up community-based filter lists. And the final thing for customers is don't send out Martians and don't send out exchange blocks. This is an example. I don't expect anyone to be able to see this, but it's certainly available on the web of a typical example of a Martian's access list. And you'll see a few kind of unique things in here. Some of the, you see kind of the standard Martians, but also included at the bottom there are a number of exchange point blocks. And those exchange point blocks are, for example, for whatever this network is or was, it's this network's exchanges. A lot of times when you peer at a certain exchange point, a NAP, exchange point, whatever you want to call it today, you can end up with that /24 inside your routing table. That's not always a good thing because, frankly, you don't own those prefixes. Those prefixes don't belong to your AS. They're not in an IRR anywhere registered to you, so you don't necessarily want to advertise them to your downstreams. Again, this is not a canonical Martians list going back. A lot of people put in the reserve blocks, the IA-NA reserve blocks or the ICON reserve blocks or whatever they are, depending on your political persuasion. A good example in this default is that, a good thing in this example is defaults are filtered out. And default routes aren't normally considered Martians, but they are in this example. And again, no exchange routes are included here under the principle that if you don't own a /24, if you don't own a prefix, even if it's floating around in your network, you probably shouldn't be advertising it. And this also, of course, applies to private peering /30s that might come from the other provider, although those are normally filtered out by prefix filters. And this is just a block diagram of how you would construct a routing policy for customer routes outbound. Deny Martians, deny exchange point blocks, match prefixes from /24 or less, and again, this could be whatever your favorite prefix filter is. Match internal routes, also on /24 or less. Match your community peers and match your community transits, and then send the routes out. And this can, of course, be written in the iOS, Junos, whatever you like. So I present it in more of a building block approach, just to make it a little bit easier. The next kind of routes we're going to look at are peer and transit provider routes inbound. In other words, if you have a transit provider, if you have a peer, they're sending you routes, what do you do with the routes? They're not usually filtered. Sometimes you filter based on prefix length. Not usually from a transit provider, but some peers will say, I'm not going to look at anything smaller than a /24. I'm not going to look at /28. I'm not going to look at /30. I'm not going to look at /32. That's not a bad thing. For peers, some set limits on numbers of prefixes, but that's relatively unusual. The nice thing about that is every once in a while, a peer will send you their full routing table and become your transit all of a sudden. So if you set some kind of reasonable limit on the number of routes, say even 20,000, 50,000, as long as you're not peering a 701, you're fine, and that can keep one of your peers from becoming one of your transits unintentionally. And meds are usually not listened to. There are networks that will listen to meds from everyone. A couple of them come to mind. But most folks don't listen to meds from transits, and most folks don't listen to meds from peers. Going to sort of a local preference hierarchy, now that we're talking about peering and transit routes, of course, customer routes are always at the top. Generally, as you move down, you get into private peering, public peering, and then transit. Now, of course, peering comes first because peering is free. Peering doesn't cost us anything, thus peering is good. There's an assumption that private peering is better than public peering. That may not always be the case anymore. There may be economic issues there, but certainly if you're still at a FIDI exchange somewhere or some kind of, let's say you have a congested link going into an ATM exchange, this can be a good thing. Now, if all of your public exchanges are gigabit Ethernet exchanges, for example, you're at a PAX, you're at an Equinix, you're here across town at NAP in the Americas, having a distinction between public and private may not be tremendously useful, and in fact, you may have private peers who you would want to prefer less than public peers just because of the size of your pipes. It can happen. And of course, transit you're paying for, so transit always goes to the bottom of the hierarchy, or at least it usually does. And AS path length is sometimes taken into account in the local preference equation. And I'll show you a little later a way to do that. And again, you use a route map or a policy statement to set appropriate communities on ingress, appropriate and unique communities. Let me show you an example, and I'm not saying this was the right way necessarily to do it, but this is an example of how one provider tried to make their local pref and their preference hierarchy a little bit smarter than the average dog, a little smarter. Basically what they're doing is it's designed to properly balance between taking the shortest AS path to a destination, which may or may not make any sense, and choosing the best outbound peer based on available capacity. So this is an example of something an actual tier 1 provider did, and it doesn't necessarily fit the right or wrong way. So here's a good example. 4 categories of peers, from best peer, better peer, good peer, bad peer. In this network, normally the private peers were the top 2 categories, the public peers are the bottom 2. Obviously good peer might be a gig exchange point, bad peer might be a FIDI exchange point, best peer might be an uncongested private peering, better peer might be sort of a full private peering session. And what you could do is you could set the local press for these based on the AS path length, where 1 being direct, 2 to 4 including pretty much everything on the internet, since most AS path lengths now are 2, 3, or 4, and maybe 5 for more distant things. Kind of strange, maybe something's really prepended, something that's obviously not to be preferred. And so there's a sliding array of local preference based on both the kind of peer and on the AS path length. And of course, because of the way the BGP decision algorithm works, normally if you're going to have a local preference hierarchy, you're never going to have an AS, you're never going to be looking at the AS path length. So this is a way of combining the local preference hierarchy stage in the BGP decision algorithm with a step that's lower, which is the AS path length. And in here, in the presentation that's on the web, there's some Cisco, Riverstone, and Juniper examples of how to do this. I'm not warranting these examples. I'm not saying you should immediately put these into your networks without checking the code. This is recycled configuration stuff that's been used in other people's networks, and some stuff that some vendor engineers helped me do for routers I wasn't familiar with. But if you follow along, you'll see the basic way to do this. And it's an interesting approach if you want to do something a little different. If you want to do something that, if you're a strongly peered network and you want to do something that'll give you, let's say, a little bit of advantage over your competitors. And you can certainly, if you want to, extend this to transit as well. There's absolutely no reason you can't put a couple additional rows at the bottom for, say, good transit and cheap transit, if you're looking for certain categories. Okay, finally, the last category are peer and transit provider routes outbound. Now, of course, there's a thing you want to accept pretty much everything you get, and you want to be conservative about what you send, to paraphrase the late John Postel. So you're usually going to when you're sending routes outbound, you're usually going to filter on the /24 boundary, or something more conservative. /24 is the least conservative thing you want to filter on. Meds are usually sent in that people aren't actually going out of their way to zero out meds before they send them, but they're rarely listened to by people on the other end, unless it's part of your bilateral peering agreement, or unless there's some kind of technical understanding on behalf of your peer's engineering team and your engineering team. And aggregates are normally announced for your own blocks. In other words, if you are a big provider with a /8 or you have some /16s, and you've sliced those up into tiny little parts that are static routes for all your customers, you're almost always going to send an aggregate out, because you could have some pretty small slices there. Now the big question is, are you going to announce that aggregate as a summary? In other words, if you have a /8, are you just going to announce the /8, or are you going to announce, say, /24 and larger within the /8 and suppress the 25s through 32s? That's kind of up to you guys, and it definitely cuts down on routing table size when you suppress everything but the /8. The problem is you're suppressing routing information as well. People who have space inside there may be trying to do stuff like send prepends out, and essentially you're throwing that routing information on the floor. That's kind of the point of the atomic aggregator bit in an aggregate. You're saying you're losing some routing information. Well, that's part of the routing information you can be losing, and your customers who are hopefully paying you may or may not like that. So my personal opinion is that you should send at least /24s and larger blocks of IP addresses out, even if you're aggregating. And then leave it to your peers. If your peers say, oh boy, they're sending me that /8 and then 800 prefixes inside that, if they don't want to listen to those 800 prefixes, that's their call, but you've done right by your customers. And again, for peers, as opposed to transit providers, the big difference is usually only customer and internal routes are announced. In other words, let's say you're my peer and I'm your peer. Rather than sending you all routes, I'm just going to send you the routes of my customers and my internal and static customer routes. I'm not going to send you routes from my other peers sitting over there. If I was, that would make me your transit provider, which may not be good. Okay, and again, here's sort of a block diagram for peer and transit provider routes outbound. Again, deny Martians, deny exchange point networks, and there can be very, very good reasons you don't want to send exchange point networks to your peers, especially if they're peering at the same exchange points you are. It could cause unfortunate routing stuff. You want to send, again, your customer routes, your internal routes with some kind of a, /24, some other number there, and you want to send the routes. Another aspect of your routing policy that's really important is your peering policy. Your peering policy depends greatly on the size of your network. If you have a tiny little network, you may not really need an elaborate, drawn-out routing policy. But it's a pretty good idea to have some criteria down and know what you want your routing policy to be today, you know what you want it to be in 6 months, when you've reached certain of your routing goals, and you know what you want it to be in a year, when hopefully you're as peered or you're getting as close to being as peered as you want to be. Some of these things are a number of locations. By that I mean, is it okay with you if you peer with someone and they're just peering down the street at the Ethernet switch? Or do you say, okay, it has to be bicoastal? Is bicoastal okay? And by bicoastal, I mean, say, East Coast and West Coast of the U.S. Or are you going to say, okay, at least 3 locations, at least 4 locations? Some larger providers will actually carve up the continental U.S., for example, into zones and require a connection in each zone. Some folks who are U.S. providers and have international routes will also require peering somewhere in Europe, links usually being the suspect of choice. So they'll say, okay, we require you to peer with us at links, and we require a DS3 going over to Europe, or these days usually more like an OC12 going over to Europe to assure enough capacity. Uniform announcements are almost always required. And what I mean by uniform announcements are, if I'm on the East Coast and I'm peering with you, and I'm on the West Coast and I'm peering with you, you have to send me the same routes on the East Coast as on the West Coast. Because if not, you may be playing games with my network and using my network to carry your traffic, which is not a right thing. Traffic balances, because of some of the strictures of hot potato routing, usually, or I should say a lot of times, there's some kind of requirement for inbound and outbound traffic to have some kind of a balance. Public versus private. Some folks, want to do private peering. Some folks won't do any more private peering. Most of the big guys simply won't do any more private any more public peering these days. They require purely private peering. And money talks. That's the big peering thing. In other words, let's say I'm going to private peer with you in 4 locations. Okay, who pays for the circuits? Maybe I have to do some facilities work. Who's going to pay for that? We like to think that peering is settlement free. There's no money involved, but there's always money involved somewhere. So the question is, how are you going to split things up to be equitable? And a lot of that greatly depends on the size of your network. So those criteria are all important things for you to think about. And you have to think about when you're talking to a network you really want to peer with, what's your position and how far are you willing to go to get that peer you really want. And these are all things that should be in writing. This is part of your routing policy. Peering criteria and procedures should be documented early. That includes your peering contacts, your requirements, your appeals procedure. Even if you're a very small ISP, if there's any reason you're ever going to say no to peering with someone, And there will be reasons every once in a while, no matter how much you want to peer, you need an appeals process. And if that appeals process is, here's my boss's phone number, well, that's great, but it's something you should have. Because the last thing you want is some Yahoo who maybe pointed a default route at you, calling your CEO and complaining because you pulled his peering. You want to have all your ducks in a row. You want to have an appeals process. And the last thing you need is a bilateral peering agreement. A bilateral peering agreement is a contract that essentially says, I'm willing to peer with you. Now, most of these BLPAs are pretty weak, and that they have things like 30-day cancellation policies, but these are very valuable to have. I mean, there's lots of large ISPs that simply say, whatever you have for me to sign, I'll sign. But it's always a good idea to have your own and to have something that your lawyers have looked at and recognized and they know it is a good thing. Most BLPAs are more or less uniform by now. Mostly because peering coordinators have moved from ISP to ISP, taking their bilateral peering agreements with them and crossing out the names, or they get other people's bilateral peering agreements and cross out the names. Every once in a while, you'll get a bilateral peering agreement from someone, and you'll really look through it carefully, and you'll see another provider's name or another peering coordinator's name that they forgot to find and replace. Oops, so it happens. Another thing to keep in mind for peering policy is, are you going to require MD5 authentication? Vario, for example, does this. Some other folks may or may not do it. You have to decide whether that's a good thing, whether that's a bad thing, whether you're vulnerable to any kind of attack. And the last thing is, don't pretend that peering is about anything other than business. I want to get on the soapbox here for a minute. Being willing to peer doesn't make you a good person, and being unwilling to peer doesn't make you a bad person. Acting like UUNet hasn't lost WorldCom any market share, in my opinion. Now, there's a lot of people who say, oh, no, it has. They're terrible people. They won't peer with me. But in the end, peering is a business decision, and it doesn't make you a bad person. Peering is the Internet's version of the selfish gene. I don't know if any of you guys have heard about this. There's a theory that human behavior is motivated essentially by selfishness. Well, whether we like it or not, peering is motivated by selfishness. Networks peer because of mutual advantage. I'm not necessarily going to peer with you because it makes me happy or it makes you happy. If I'm doing my job right, I'm going to peer with you because it makes my network better. And if it happens to make your network better, well, that's a collateral benefit. That's why you're doing it. Now, this isn't a license to be unreasonable, and this isn't a license for people going to NANOC to get intoxicated and yell, I've got peering, and you don't, which has happened once or twice. Not peering when you should is your own punishment. If you should peer and you don't because you're a jerk, well, you're not doing a very good job. It's not only bad PR from someone who may eventually be a customer of yours and now who maybe won't, or maybe someone who would have been a partner of yours, or maybe someone who would have acquired you eventually, but it also can lead to decreased customer satisfaction. Going on a little bit in routing policy, there's the question of customer requirements. In other words, an essential part of your routing policy are, what are the requirements on your customers? Usually these are the requirements for bringing up a BGP session with you, because until a customer brings up a BGP session with you, they're part of your routing domain for all intents and purposes. Things are like iOS and Junos versions. In other words, are you going to bring up BGP peering with someone running iOS, 10.1, just to pick something out of the air, or Junos 3.4, whatever the number should be? Are you going to have some kind of minimum requirement there? MD5 authentication again. Are you going to require your customers to have MD5 authentication? And the bigger question is, are you going to support MD5 authentication when someone, let's say a major financial institution, calls and demands that it be turned up? Requirements for customer-side filters. Most ISPs require customers to have filters in place. And of course, you can't assure this. You don't know for sure that your customer has the filters in place, but you can have the policy that says customers must have filters in place, only sending certain prefixes, the prefixes they're authorized to send. And there's also a rather unusual requirement, again, to pick on Digex that they do, for demanding second announcements. And this is something I haven't seen from anyone else, and I'm sure other people do it, but there are certain providers who will say, we won't ever take a BGP announcement from you first. In other words, if you're going to advertise 10/8, which of course you never would, and you're going to announce that to us via BGP, we always want to see it second. You can never turn it up with us first. And I'm sure there's reasons for doing that. Not exactly sure what they are, but that's a more uncommon requirement. Finally, authentication of NetBlock ownership. This has become a much larger issue recently. In other words, you know, in the old days, and then, of course this is the internet, so the old days is like 3 years ago. In the old days, if someone said, I own block X, I'm going to start announcing it to you now, you said, okay, you know, start announcing and I'll change my filters. These days, you know, things aren't quite so trusting, and the ownership of net blocks is not quite so obvious. There have been a lot of mergers, there have been a lot of acquisitions, there have been a lot of, we see that projector there? That projector has a /8 with it, and I'm selling it as a subsidiary to you. So now you own a /8. There's been a lot of that going on. So there have been a lot of efforts to authenticate net block ownership. You know, some of that's been done through IRR records. Of course, IRR records are not famously accurate. Some of that's done through Aaron, Ripe, and Apnick Whois, which I think tends to be a little more accurate. Okay, community specifications. Communities are the heart of a routing policy. Communities allow you to classify routes. Again, why classification? Filtering, diagnosis, and being able to change attributes. Let me give a brief analogy. You know, there's a vast sea of routes, over 100,000 routes. Communities, well, you call some routes tuna and other routes salmon, instead of just calling all routes fish. You know, it lets you classify and split routes up into more easily definable sets. Now, communities are not groups or sets of routes. The best way to think of a community is like a sticky note, a Post-it note. A community is a label or a number or string that you stick on a route. And by looking through your whole list of routes for that string, for that label, you can come up with a set. But it's important to realize that communities aren't like ordered sets of routes. They're simply labels or strings that you put onto routes. Okay, you know, this is of course the obligatory where our communities defined. Communities are defined in these great RFCs. You know, BGP community attribute 1997, 1998. Typical community format is 32 bits, divided into 2 parts, usually a local AS and a value. Although there's nothing in your routers that will enforce, you know, the first 16 bits being the local AS. That's in practice what pretty much everyone does. There are also some well-known communities. These well-known communities are defined through RFC by the ITF, stuff like no export, no advertise, and no export subconfig. These tend to work the same no matter what router you're on, although there have been known to be some differences. And if you look in the documentation for some routers, some of these communities may be called something a little bit different. They may even be called something a little bit different than what the IETF calls them in the RFCs. The best way to know for sure what you're dealing with is to look at what the actual community value is set to. Because that community value that's defined in the RFC, the actual numerical value will be the same across all router implementations. There's also currently a proposed well-known community, unless this internet draft has expired in the last month, for no peer. And this is a great idea. And so everyone who's going to IETF should definitely support the idea of the no peer well-known community. Basically what no peer means is that routes within this community are advertised to customer ASs only and not peer ASs. The internet draft is up there, draft Houston, no peer. Most large providers already have a community like this. The community, what that community number is and the exact behavior of it differs from provider to provider, but this is a great idea. And if you want to know who comes up with this and to get involved with them, it's the IETF Interdomain Routing Working Group, which is a fine organization. There have been other proposed well-known communities in the past. They've never made it in. I think this is a good one, so people should try to get out and support this. Okay. Now, what do I get out of implementing a routing policy with communities? You know, why should I go to all this trouble? Communities are a lot of work. You know, I have to change my router configs. I have to write up this policy. You know, why am I doing all this? The reason is, again, it's easy to send all routes, or it's easy to send 5 routes or 10 routes. The problem is sending 1,000 routes. The problem is sending 10,000 routes. That's a tough issue. It's tough to enumerate all those. It's easy to enumerate 5 ASs if you want to send those to a peer. It's hard to enumerate 100 ASs and have that list of 100 ASs be the same in all your peering routers. That's where communities come in. Again, communities let you classify and tag routes upon ingress to your network, allowing easier filtering of those routes upon egress of your network. Don't be the network operator who has to touch his peering routers, all of his peering routers, every time they add a customer. Because of course, if you're peering and you add a customer, well, that affects the routes you want to send. The easy way to handle that is to do it with communities. The not easy way to handle that is to do it with AS path lists on all of your peering routers. That is a bad thing. Now, some of the typical types of communities you can have are geographical, route type, egress information, pure AS or exchange point, and RBL, and of course some other miscellaneous uses. Jumping into this, geographical, again, marketing, ingress, POP, region, continental are generally the three basic ways people like to use geographical classification. By POP, depending on how many POPs you have, and of course if you have more than say 10,000 POPs, this won't work very well, every POP can have a distinctive community. Every region can have a distinctive community. Most service providers that are big in North America will split North America into say 6 or 12 regions and mark them with a community. Some large international carriers will have continental or country routes. In other words, US routes, European routes, Brazilian routes, Belgian routes, whatever you decide to have. That enables you to do things like have one global AS and have European routes to send to your European peers and US routes to send to your American peers, or US and European routes to send to your American peers, depending on what your policy is. Again, here's an example of some communities, pretty straightforward. As far as route type classification, this should look familiar. This kind of parallels the local preference hierarchy. Customer routes, customer backup routes, private and public peering routes, transit provider routes, and internal routes. And it's not infrequent to see that whatever the local pref values are generally the same as the last 16 bits of the community. So in other words, if you're setting your private peering routes to have a local preference of 150, it's very, very common that a transit provider, which could be you, is going to say, okay, if my AS is 65,000, that if my local pref for private peering is 150, my community for private peering routes will be 65,000:150. It's a very nice, easy way of remembering these things. And the thing to remember here is when you're troubleshooting, you want stuff that's easy to remember. Some folks like to construct communities through sort of a matrix approach. In other words, the first digit of the community value means one thing. The second digit means something else. The third digit means another thing. The problem is when you're troubleshooting your network, the last thing you want to have are 10 big charts so you can decipher what the community is for all the routes you're looking at. It's better to have more little communities that you remember what the values are. Handier. Okay. One of the features you can add through the use of communities is something called selective prepending. This is a really neat, cool feature. What this allows you to do is it allows your customer can always prepend routes to you, right? They can always add additional autonomous systems to the AS path. They can do that to you all day long. But wouldn't it be cool if they could prepend selectively? In other words, if you have, let's say, your simple network with 3 transit providers, wouldn't it be great if they could only send prepends to one of your upstreams? Let's say you have 50 peers. Let's say they only wanted to send prepends to 5 of your 50 peers. This sounds like something that would be incredibly difficult to implement, but it's actually pretty nice and straightforward. And what this allows your customers to do is to gain finer control of their incoming traffic. And you have to decide who you want this enabled towards. In other words, if you have 200 peers, that can lead to some kind of long router configs if you want to enable this towards every one of your peers. You can say, okay, I just want to enable this towards transit providers, I just want to enable this towards peers, I just want to enable this towards my largest peers. That's a good decision to make before you get into it. And of course, the most important thing here, and it's something that Cable and Wireless recently did, is if you're going to publish this, and to make this worthwhile, you have to publish your communities to your customers, you're going to be documenting who you're peering with. Now, for most people, this isn't a big deal, but for some people for whom peering is a dark, deep secret, this could be kind of prohibitive. An example here of how to do this is, let's say your AS is 1234. You could have a community 1234:4701, and what this would mean is that one of your customers could send you this community, and what would happen is that you would prepend their route announcements only towards 701 4 times. And of course, it would probably be your AS being prepended onto it. There's usually a maximum number of prepends, usually something like 5 or 6, sometimes even 1 or 2. The more prepends you want your customers to be able to add, the longer and more complex your router configs are going to be. This is normally implemented with a separate route map or policy statement for each one of your peers, with a separate section for each case. No prepend, one prepend, three prepends, whatever. So here's basically a quick chart of how to do this, and we'll skip over this pretty quickly because you're going to see an actual configuration example of how to do this as well. But essentially what you're doing is you're going to deny Martians, deny exchange routes, match community customer routes, and then you're going to go down and say, okay, there's going to be a community called prepend this provider by 1. So then I'm going to prepend by 1. And the same for, you have a separate term for however many prepends you want to be able to do to each particular peer. No peer. This is, again, the proposed well-known community, but that many people have implemented with their own communities. Okay, again, no peer. No peer is kind of a variant of the AS prepending, but what we're doing here is instead of, actually, no peer is essentially saying, I don't want to send, I'm getting routes from my customer, and I want to send them to my customers, and I want them to be floating around in my internal network, but I don't want to send them to any of my transit providers, and I don't want to send them to any of my peers. So essentially, this is a way for one of your customers to kind of simulate peering with you. Of course, they're not actually going to be on your peering routers, and of course, they're going to be paying for transit, but it's still a way to kind of pretend to be a peer. And there's good and bad reasons for doing this. And here's an example format, 1, 2, 3, 4, 6, 6, 6. This is not an uncommon community. So, selective suppression. This is sort of a variant of selective prepending, but selective suppression says that, let's say, again, I'm the transit provider and I have 50 peers, and you're my downstream customer. You as the downstream customer may say, I want to send routing announcements to 40 of your 50 peers, but I don't want to send routing announcements to 10 of those peers. Something like selective suppression would let you drop those routing announcements towards some of your peers or towards some of your transit providers. And again, this is another way for customers to gain finer grained control of incoming traffic. An example of this is, for example, 123.4:9701. That could be the code, for example, where 9 says, suppress this. 9 says, don't send any of my route announcements towards AS701. Again, here's sort of a block diagram of how to do selective suppression. And typically what's happening here is you'll do no peer first. After your no Martians and no exchange networks, you'll look to say no peer, and no peer will be in common between all of your routing policies. And you'll move on to do your selective prepending. And here there's just an example of prepend 1. And of course you can have as many prepends as you want. And moving down a little farther, there's the selective suppression, match community suppress, and then you deny the route. And here's some, we won't go through these here, but they'll be in the slideshow that's on the web. Configuration examples for how to do this for Cisco, Riverstone, and Juniper. Should be relatively useful. There's some other communities that you may or may not want to set. Peer AS community is pretty common, and by peer AS community I mean if you guys are my peer and you guys are say 701 and I'm 1234, I may want to tag all of your routes that are being sent to me 1234:701, just as a way of me saying, okay, I know what AS that came from. Not terribly necessary if you can look at an AS path, but it can be useful under certain circumstances. The other thing some folks do are exchange point communities. In other words, if I'm at, say, 5 exchange points, I may or may not want to mark routes with communities that are unique to that exchange point. Some folks do that by having a special POP community for a specific exchange point. The final kind of community you may or may not want to add, and this one is a little controversial, I'm not necessarily taking a position on this, is RBL routes. In other words, there's something called the real-time black hole list, and there may or may not be other services like this that say there are certain prefixes out there in the world that contain bad people. Maybe they're spammers, maybe they're other kinds of people, and you're given the option of not sending any traffic to them. So what you could do is eBGP multi-hop here with their AS, which would be 7777, and that would allow you to black hole prefixes which may contain spammers. Of course, they may not contain spammers. So it's kind of a two-edged sword whether you want to do this. Again, I have absolutely no opinion on whether the life should be crushed out of scumbag spammers. No opinion there at all. But if you are interested in this, there's a URL up there that you can check out. I have to say, I've never personally used this service, but it is sort of an interesting twist. So to kind of wrap things up, why go to all this trouble? This seems like quite a production. I'm going to have to write this huge policy. I'm going to have to keep it updated. I have to change all my router configs. So why do I do this? You know, there are a couple good applications. Selling transit, scalably. Getting peering, scalably. Troubleshooting your network, which may mean for you getting, especially the guys here, maybe being paged at 2 a.m. fewer times because your NOC guys can figure out what's going on, because things are going to be documented and there won't be quite as much tribal knowledge, and enhanced flexibility. So let's go, just to take the conclusion one step filter, writing it up. What do you have to write up to get a routing policy? Well, here's a couple things. Your community system, where your list of communities are, your local preference hierarchy, which can be tightly bound into your community system, your list of atomic policies, and by atomic policies, I mean all the individual routing policies. Those are the individual route maps and the individual policy statements that are in your router configs. You have all these tiny little configurations in there, and it's often useful not to have the configurations written up, but to have the purpose of each of those configurations written up. This is very handy if you have a multi-vendor network. You have Cisco, you have Juniper, you have Riverstone, you have Foundry, you have Extreme, you have all these different vendors. You want your configurations to be very parallel between all the different vendors. Having a list of atomic routing policies, in other words, no Martians, and not necessarily having the Cisco iOS code for no Martians, but maybe a really good write-up on what no Martians does, what the purpose of no Martians is, what no Martians hopes to accomplish. That can really help you port your router configs from one platform to the next. It's also a great training tool for your NOC guys and for your lower-level network engineering guys. You want to write up of your filtering policies, and then your IP prefix filtering policies. You want to write up of your peering policies, and also a write-up of your policies for interaction with BGP-speaking customers, whether it's through IRR auto-generation, whether it's through a form, whether it's through a Java applet, and whatever your policies are. All of these things should be written up. These are sections in a document that you can produce. Questions? Questions, please. We have about 20 minutes. Any questions? Ma'am?
This has been very helpful in talking about the policies to be written out, but what about monitoring the policy once you have in place and making sure that you are complying with the same policy?
Okay, the question was monitoring, and monitoring can be tricky. For some of these things, people will help you monitor them. There are certain peers out there like Genuity that if you start sending unequal routing announcements, they'll send you helpful emails two or three times a day. Thanks. But this is one reason why it's useful to have kind of a high-level network engineering group that's writing these policies and that's writing your configurations, and who can go and actively investigate and make sure that these things are happening. You know, as was said in the last tutorial, using something like Rancid or using another configuration checking tool can help this a lot, because you can check and see that these atomic policies that should be in place for every router configuration are still in place. You can also do some analysis of what BGP announcements you're making, and that's pretty useful, is having a peering group or maybe a peering coordinator who's clueful enough to actually look at what routing announcements you're making and determining if they're in accordance with your peering policy. And of course, the best way to do all this is automation. None of this should be done by hand. Everything should be automated using expect scripts, using Perl scripts with net telnet or other modules. Does that answer your question? Other questions? Anyone? Heckles? So I guess not. Special thanks real quick to Greg Hankins with Riverstone, who helped me out with some of the Riverstone configs, which are outstanding. Miguel Dumayuga, who's currently at CBeyond Communications, couldn't be here, who helped write some of this stuff. And Jason Weil and Scott Patterson at Cogent. So thank you very much.